Rate of change definition. Rate of change is a value that results from dividing the change in a function of a variable by the change in the variable velocity. Variable velocity is the rate of change in distance with respect to time. Other than that, the rate of change of a quantity refers to how that quantity changes over time. Rates of change are commonly used in physics, especially in application of motion. Typically, the rate of change is given as a derivative with respect to time and is equal to the slope of a function at a given point. The rate of change of a function varies along a curve, and it is found by taking the first derivative of the function. The derivative dy over dx of a function yx is the rate of change of that function at the point x, y, x. The rate of change at a specific point is known as the instantaneous rate of change.
Now, moving on to the next question. Why we use rate of change? How is rate of change used in real life? Rate of change can be experienced in a real world, analog to rates of change every time you drive a car, ride a bike, or move at all for that matter. Position, velocity, acceleration, and are all in the same sequence of derivative and integral. The fundamental theorem of calculus is a model with pervasive application. Now, for the third one is how to use rate of change. A rate of change is a rate that describes how one quantity changes in relation to another quantity. If xx is the independent variable and yy is the dependent variable, then rate of change equal to change in y over change in x. Rates of change can be positive or negative. This corresponds to an increase or decrease in the yy value between the two data points. When a quantity does not change over time, it is called zero rate of change. For positive rate of change, when the value of xx is increased, the value of yy increases and the graph slants upward. Next, for the negative rate of change, when the value of xx increases, the value of yy decreases and the graph slants downward. For the zero rate of change, when the value of xx increases, the value of yy remains constant. That is, there is no change in yy value and the graph is a horizontal line.
This is Adam. Adam is a student majoring in mathematics. This is Miss Amanda. Miss Amanda is Adam's lecturer. Miss Amanda instructed her students to find real-life situations that they can apply into their studies as an end of the semester assignment. As Adam wonders about what should he write in his assignment, he remembered he had tickets to a race car competition that was being held on that weekend. As Adam watched the race competition, he was amazed how fast a Ford race car could go. He wanted to know how fast the car was going, so he thought using the rate of change of the circuit area can be of use to find its speed. Back at home, Adam started with the calculation, but he's having trouble calculating the problem. Question: calculate the speed of the Ford car by using the rate of change of circuit area and radius of the circuit. Given the rate of change of the circuit area is 250 km per hour and the radius is 2 km.
Now I'm gonna show you how to get the speed of the car. First, we need to list all the information we can get from the question. The circuit, the radius, which is 2 km, sorry for the typo. The area of the circuit A equal to pi r square. The perimeter of circuit B equal to 2 pi r. And the speed of the race car S equal to differentiate P, which is differentiate 2 pi r, and we will get 2 pi dr per dt. So now we need to find what is the dr per dt, or the rate of change of the radius. So, given by the question, the rate of change of the area of circuit is 250 km per hour and the radius is 2 km. So, from that two information, we can get the rate of change of the radius. Now, I will show you how to get the rate of change of radius by using the rate of change of the area of the circuit. We can simplify that differentiate A is equal to differentiate pi r square. From that, we can substitute the value of dr per dt with 250 and the differentiate of pi r square will be 2 pi r dr per dt. Then, dr per dt will be equal to 250 over 2 pi r, which is 2. Now we already get the dr per dt. Now it's time to find the speed of the race car. So now the formula for speed of the race car is 2 pi dr per dt. Then from the formula, we just substitute the value of dr per dt into the equation.